So here's a video on lesson 56, transformations of sine and cosine 3. Our goal here is to describe the transformations that have occurred on each one of these sine or cosine functions. And just as a key, we decided to explain first what each one of these letters does. Now the generic letters that we pick for these constants, these numbers that we don't know, is A, W, H, and K. So A is attached to the front. It's attached to the front of the sine and the cosine. It's a coefficient. It's attached to the multiplication. A is going to be the amplitude. And an example for that would be like 4 sine of x. That 4 would be the amplitude. That's how far up and how far down the function goes from the midline. So like this would be 4 as a distance. Next is the last number, the plus k. The plus or minus at the end is going to be the midline. Y equals k would be the midline. So for my example here, cosine of x plus 2, make the eraser smaller. So cosine of x plus 2 is going to have a midline of y equals 2, positive 2. That would be the midline. So that means like if I had a cosine function, this would be the midline. Y equals 2. H, an addition or subtraction on the inside of the function right next to the x, that's a horizontal shift. What you need to know is that adding a number moves it to the left and subtracting a number moves it to the right. It's the opposite of what you would normally think. So this sine of x plus 4 means that this is moved left 4 units. That's talking about this example right here. And W is the frequency. So W, coefficient on the x on the inside, is the frequency. It tells you how many complete cycles of the function you'll get between 0 and 2 pi. So for instance, question number 4, I gave you an example. I said, let's say sine of 3x. Well, sine of 3x has a frequency of 3. That means that between 0 and 2 pi, we have 1, 2, and 3 cycles of sine. So that's 1 here, and 1 here. 1, 2, 3. Okay, so that's a rundown of what all these things mean. Now your goal is just to identify the frequency, amplitude, midline, and any horizontal shifts on all the following functions. So I'll go through 1 or 2 of them. Number 12. The amplitude, there we go. The amplitude is the first number, so the amplitude is going to be 6. The midline is always the next easiest to identify. So the midline would be y equals -4. And 6 and -4. Now, the 4, that's going to be the frequency. And the -3 on the inside means it has a horizontal shift. Let's call that HS. 3 units in what direction? To the right. I'll do 14 as well. The amplitude is equal to 8. The midline is y equals 5. There is no multiplier, right? So that means that the frequency is just going to be 1. And it has a horizontal shift. 5 units. What direction? Right. Now let's flip to the back. Because on the back, we start talking about period. Period is a new attribute, as of lesson 56, that functions have, and is related to frequency. So period is the distance horizontally needed to complete one cycle of a function. So that means, for instance, if I said that I had a sine function and it took all the way until 3, whatever 3 is, that would mean that the period is equal to 3, because it would be like 1, 2, 3 units. Right, so it's the distance required along the horizontal midline. We get two formulas from this. Period and frequency are related. So period is equal to 2 pi divided by frequency. And it turns out, with a little algebra, you find out that frequency is also equal to 2 times the period. Period does not go into the function. Period gets converted with this formula into frequency, and we put frequency into the function. So watch one example of that. Question number 2. What is the period of the function 5 sine of 3x? So they want the period. What's period equal to? 2 pi divided by the frequency. Now which one of these is the frequency? Is it the 5 or is it the 3? 5 is the amplitude. It's 3. So we get 2 pi over 3. And that can't be simplified, so that's actually the final answer. That's the period. If I had another example like number 3, 1/2 sine of 6x, this right here is the frequency. Nicer F. There we go. That's the frequency of 6. So period is equal to 2 pi divided by frequency, which is 2 pi divided by 6, which could be simplified into 1 pi over 3, because 2/6 is also 1/3. And then I actually don't need to write 1 pi, I could just write pi. So pi over 3 is how I would write that final answer. Now the rest of the handout was just asking you for the period of a function. You were just using the same formulas. And the only thing that was interesting or any different was question number 8. Now, what you had to do was you had to look. If I want the period, I know that the period is equal to 2 pi divided by the frequency. But frequency is normally like being multiplied on the x, so like 4x or 2x, something like that. But this doesn't have any multiplication going on, it's x divided by 3. So here's the equivalence that I use. X divided by 3 is equal to 1/3 x. I can change that to make it into multiplication instead of division. So I'll rewrite this equation, y equals 1/2 sine of 1/3 x minus pi. Now it should be obvious by now that this is going to be the frequency. If I plug that in here, I get 2 pi divided by 1/3. And when do I divide by fractions? Never. So instead of dividing by a fraction, I'm going to keep, change, and flip. So I keep the 2 pi, I change it to multiplication, and I flip the 1/3 into 3 over 1. Well, 2 pi times 3 is going to be 6 pi. And that's my final answer for question number 8. If you have any questions, please feel free to see me during class or in office hours.